a cosmic journey into the mysterious realm of rogue planets is undertaken. The captivating possibility of these celestial wanderers outnumbering stars in the universe is explored. Imagine a universe where the familiar twinkling stars are actually outnumbered by unseen, wandering worlds. What if the cosmos is teeming with billions upon billions of planets, not orbiting any star, but adrift in the cold, dark expanse of space? Prepare to have your perception of the universe fundamentally shifted as we explore the captivating possibility of rogue planets being more common than stars. Forget everything you thought you knew about planets. We're about to unveil a revolutionary concept that could rewrite our cosmic census. What if the majority of planets in our galaxy, and perhaps the entire universe, aren't bound by a sun, but are instead vast, free, floating giants roaming the interstellar void? Get ready for a mind-ending journey into the incredible truth about rogue planets. Look up. Above you, the night sky unfolds like an endless tapestry of glittering points. Stars, countless and eternal, scattered across the heavens. For millennia, we believed they were the fixed landmarks of the universe. Anchors, guides, the very rulers of the cosmic stage. We told stories about them. We charted our journeys by them. We believed they were the dominant population of the sky. But now, we must consider something far more astonishing. What if those twinkling lights are not the majority? What if, hiding in the vast darkness between them are worlds, not a few, not hundreds, not even millions, but billions, perhaps trillions, worlds that do not orbit stars, worlds that drift unseen through the cold interstellar void, worlds that we call rogue planets. Imagine it. A planet as large as Jupiter, hurtling silently through space. No sunrise, no sunset, only endless night. Its skies are black, its surface frozen, silent and strange. Perhaps mountains of ice rise into perpetual darkness. Perhaps hidden beneath its crust, oceans stir with unseen energy. And there it drifts forever, a lone traveler in the cold galactic sea. These are the invisible giants of space. And some scientists now believe they may actually outnumber the stars themselves. For centuries, we assumed that planets were rare, that stars were the dominant actors in the galaxy, and that planets were lucky companions orbiting like dancers around a central flame. Then, in the last few decades, we learned the truth. Planets are everywhere. Nearly every star we study has them. Many stars have entire families of them. But then came the next revelation. Not all planets are bound to stars. Some wander. Some have been exiled. Some were never tethered at all. And once we dared to imagine them, we began to see evidence that they are not rare curiosities. They may, in fact, be the majority. Think of what this means. The stars you see above you, as numerous as they are, may be outnumbered by the planets you cannot see. The night sky, with its glittering constellations, may be but a fraction of the true population of the cosmos. For every star that shines, there may be 1 to 10 dark, drifting planets, unseen, silent, waiting. Tonight, we begin a journey into this mystery. We will explore what rogue planets are, how they form, how we might find them, and what their existence tells us about the galaxy we call home. We will ask, could life exist on such worlds? Could oceans stir beneath their frozen shells? Could heat from within sustain hidden ecosystems, just as it does on Earth's deep ocean floor? And finally, we will imagine a future where humans venture into the darkness, where we may one day visit these wandering worlds and find in them a new kind of frontier. As you listen, allow yourself to drift. Picture yourself traveling through the Milky Way. Stars scatter across the distance, but in the great dark oceans between them, worlds float silently. They do not shine. They do not call attention to themselves, but they are there by the billions. They are the secret majority of the cosmos, and tonight, together, we will reveal their story. Welcome to the invisible universe of rogue planets. What is a planet when it has no star? For most of human history, we defined planets by their relationship to suns. Mercury, Venus, Earth, Mars, each one circling the bright furnace of our star. Farther out, Jupiter, Saturn, Uranus, Neptune shared companions bound by gravity to the same central flame. Even the planets we discovered beyond our solar system, the exoplanets, were understood in the same way. They orbited stars. They belonged to systems. They were part of a family. But rogue planets defy this definition. They are wanderers, nomads, orphans of the galaxy. They drift freely through interstellar space. No sun to guide them. No parent to warm them. No orbit to trace their path. They are planets by their size and nature, but by their destiny, they are something else entirely. Imagine holding a globe of Earth in your hands. Now remove the sun from the picture. Let the Earth drift away into infinite night. No day. No year. Only eternal journeying. That is a rogue planet. Some are rocky, like Earth or Mars. Others are gaseous, like Jupiter or Saturn. Some may be small, barely larger than asteroids. Others could dwarf even the greatest giants we know. And yet, all share the same fate, exile from the warmth of a star. But how do such worlds come to be? Astronomers suggest two main paths. First is exile. A planet forms in the cradle of a young system, orbiting a newborn star. But in the chaos of birth, things go wrong. Perhaps a massive planet pushes it aside. Perhaps a nearby star tears at the system with its gravity. Perhaps a violent collision flings it free. Whatever the cause, the result is the same. The planet is hurled into space, cast away to wander forever. The second path is even stranger. Some rogue planets may form directly in the interstellar medium. Clouds of gas and dust collapse, not into stars, but into planet-sized bodies. They never had a sun to begin with. Were born free. When we call them rogue, it is not because they chose to leave. It is because their fate has made them outsiders. They exist outside the system, outside the orbit, outside the light. But don't mistake them for rare oddities. Evidence suggests they are as natural a part of the galaxy as stars themselves. They are not exceptions. They may be the rule. Think of the poetry in their existence. Stars burn bright, demanding attention. They shine, they flare, they command the sky. But rogue planets slip through darkness unnoticed. They are subtle, silent, patient. They are the hidden population. Somewhere, even now, a rogue planet may be passing within a few light years of Earth. Not orbiting. Not glowing. Simply drifting by, unseen. To define rogue planets is to challenge our imagination. For what is a world, if not a place with a sun? What is a planet, if it does not belong to a system? And yet, these worlds are very real. They have mountains, valleys, storms, atmospheres. They may have oceans, continents, or ice sheets. They are full-fledged planets, just without the light that makes them visible. Let us return for a moment to Earth. Strip away the sun. Temperatures plummet. Oceans freeze. Atmospheres collapse. And yet deep inside, the Earth still stirs. Heat from its core would remain. Energy from radioactive decay would continue. Life, at least in hidden pockets, might survive. Now imagine billions of Earths, millions of Jupiters, scattered through the galaxy in darkness. That is the reality of rogue planets. Scientists sometimes call them free-floating planets. Others call them orphan planets. But whatever the name, the idea is the same: planets without homes, wandering endlessly, part of the great unseen structure of the cosmos. They remind us that our definitions are fragile. For centuries, we assumed that a planet meant something that goes around a star. Now, we know better. Planets do not need stars to exist. They can roam the galaxy alone, and in vast numbers. And so, the definition of a rogue planet is simple, but the implications are profound. A planet without a star. World adrift in the void. A reminder that the universe is more complex, more mysterious, and more abundant than we ever dared to dream. Welcome to the true identity of rogue planets. The cosmic wanderers. The invisible majority. The orphans of the Milky Way. To understand rogue planets, we must return to the beginning. The birth of stars, the birth of systems, the birth of chaos. Stars are born inside great clouds of gas and dust, known as nebulae. Within these nurseries, gravity gathers matter into dense clumps. Some clumps grow massive enough to ignite into stars. Around these young suns, leftover material swirls in vast disks. It is here, in these swirling disks, that planets take shape. Tiny grains of dust collide. They stick. They form pebbles. Pebbles grow into rocks, rocks into boulders, boulders into worlds. This is how planetary systems begin. Order from chaos, worlds from dust. But in this same process, exile is born. Picture a young planetary system. Several massive worlds form, each tugging on the other with invisible threads of gravity. Jostle. They shift. They disturb the delicate dance of orbits. One world strays too close to another. It is hurled outward like a stone flung from a sling. Its orbit stretches further until it snaps free of the star entirely. In a single moment, it is cast away, a planet now a wanderer. There are many ways such exile can happen. A newborn star may have siblings. Stars often form in clusters, dozens or even hundreds at once. Their gravities mingle. One star passes too close. The balance of the system is shattered. Planets are scattered like marbles across the galactic floor. In other cases, a giant planet, perhaps the size of Jupiter, throws its weight around. Smaller worlds are pushed aside. Some fall inward, consumed by the star. Others are tossed outward, into permanent darkness. Sometimes, two planets collide. The wreckage reforms into one world while fragments are flung beyond escape. Every path leads to the same fate, a planet cut loose, a world without a sun. And then there are those that never knew a star at all. Imagine a clump of gas in a nebula, too small to ignite as a star, too large to remain just a ball of dust. It collapses, forms a planet-sized body, and drifts away. From the very moment of birth, it is a rogue, a child of the galaxy, but never of a system. The violence of formation means rogue planets are not rare accidents. They are natural outcomes of cosmic birth. For every system that survives intact, countless others lose members to the dark. Our own solar system may once have had many more planets. Some theories suggest a fifth giant world once orbited between Saturn and Uranus. Long ago, it may have been hurled out, a lost sibling, drifting somewhere in the Milky Way even now. We will never know its name, but it may still exist, unseen. Think of the scale of this process. Every star you see at night was once born in a nursery of dust. Every one of those nurseries created planets, and in the violent shuffling of orbits, many of those planets were ejected. Multiply this by billions of stars, and you begin to glimpse the magnitude. The galaxy is not only filled with ordered systems like ours, it is filled with debris, exiles, wanderers. It is filled with rogue planets. There is something profoundly human in this story. A world begins with a family. It circles its star, bound to a system. Then, through no fault of its own, it is cast away, below, unseen, adrift. And yet it endures. It continues to exist. It continues its journey, silent and eternal. Perhaps that is why the idea of rogue planets fascinates us. They are cosmic exiles, mirroring our own feelings of loneliness and survival in an immense universe. Scientists studying planet formation now accept that ejection is common. Simulations show that in the first few million years of a system's life, planets collide, scatter, and fall like pieces in a great cosmic game. Some remain. Some are destroyed. And many are lost to the interstellar dark. It is not the exception. It is the rule. So how do rogue planets form? They form from the same dust and gas as all other planets. But in the chaos of youth, their fates are altered. Some are expelled by giant neighbors. Some are torn away by passing stars. Some are shattered in collisions. And some are born free, never bound to light at all. Every rogue planet is a story of creation and exile. Every rogue planet is proof that the universe is not only orderly, but also restless, violent, unpredictable. And for every star you see shining in the night sky, there may be many more worlds, invisible adrift, telling the same story in silence. Rogue planets are not mistakes. They are not anomalies. They are the natural children of a chaotic cosmos. And as we begin to recognize their abundance, we realize something profound. The universe is not simply a place of stars and their companions. It is a galaxy of wanderers. A galaxy where exile is destiny. A galaxy where darkness hides countless worlds, each one with its own untold story. For much of history, rogue planets lived only in the realm of imagination. Philosophers and poets dreamed of worlds adrift, but astronomers had no way to prove such things existed. The telescope, for all its power, shows us what shines. Stars glow. Planets reflect light from their suns, but a planet without a star is cloaked in darkness, invisible. To human eyes, a rogue planet was like a ghost, there, but unseen. It was not until the late 20th and early 21st centuries that this began to change. In the 1990s, we first confirmed the existence of exoplanets, planets beyond our solar system. Even this was revolutionary. The idea that other stars had their own families of worlds moved from speculation to fact. And with this discovery came a deeper question. If stars everywhere had planets, could some of those planets be free, floating? The hunt for rogues began. Astronomers needed indirect methods. They could not rely on light, but they turned to gravity itself. One technique was gravitational microlensing. When a massive object, like a rogue planet, passes in front of a distant star, its gravity bends and magnifies the starlight. The effect is subtle, but detectable. In 2011, a team of researchers using this method made a stunning announcement. They had found signs of objects as massive as Jupiter, but not orbiting any star. Their conclusion was bold. Rogue planets may be as common as stars in the Milky Way. The world was astonished. Suddenly, these invisible wanderers were no longer just theory. They were real. Other clues soon followed. In young star clusters, astronomers spotted faint, cool objects that seemed too small to be stars, yet too large to be brown dwarfs. Some of these, they realized, were likely rogue planets, still warm from their formation, glowing faintly in infrared light. The Subaru telescope in Hawaii, the Very Large Telescope in Chile, and eventually the Spitzer and Hubble space telescopes, all contributed to this growing picture. One by one, the evidence mounted. 3 floating worlds exist, and there may be many of them. Think of what it meant for science. For centuries, we assumed the universe was built of stars. Now data hinted at a hidden population, lurking in the shadows, perhaps more numerous than the stars themselves. It was like suddenly discovering that beneath the surface of the ocean, there is another ocean, vast and teeming with life, that had always been there, but unseen. The discoveries also changed how we viewed our own solar system. Was Earth unique in its stable orbit? Was it possible that in the distant past, our system had cast out its own wanderers? Simulations suggested yes. Models of planetary formation showed that ejection was common. Our own cosmic family may once have had more members, now lost to the void. Perhaps even today, a rogue sibling of Earth or Jupiter drifts quietly in the galaxy. We may never know its name, but it may exist, carrying the memory of a system it once belonged to. As the evidence grew, so did the imagination of scientists and writers alike. Rogue planets appeared in novels, in films, in speculative discussions about life and the cosmos. They became symbols of loneliness, but also of resilience. Worlds without stars, but still worlds nonetheless. The early discoveries were only the beginning. They were glimpses, shadows passing in front of distant light. But they opened the door. They told us, the invisible is real. Darkness is not empty. It is full. And so, the hunt intensified. Today, astronomers are preparing for the next leap. The Nancy Grace Roman Space Telescope, launching in the years ahead, will survey the sky with unprecedented sensitivity. It is expected to find hundreds of rogue planets, perhaps more. With each new detection, we move closer to answering the staggering question, how many are there? How many silent wanderers drift between the stars? The first discoveries changed everything. They turned a dream into data. They transformed rogues from myth into measurable reality. And they set the stage for the revelation to come, that these dark planets may not just exist, but may dominate the galaxy. Rogue planets are no longer just whispers in the void. They are known. They are counted. They are real. And their story is only beginning. How do you find something that does not shine? A star is easy. It burns. It glows. It calls attention to itself. Even distant galaxies, billions of light years away, can be seen because their light reaches us. But a planet without a star, it reflects nothing. It radiates almost nothing. It drifts, dark and cold, through interstellar space. To the human eye, it is invisible. To the telescope, it is a ghost. And yet, astronomers have found ways to track the unseen. The most powerful tool is gravity itself. Not light. Not heat. But the bending of space-time. When a massive object passes in front of a distant star, its gravity warps the light from that star. The star seems to brighten, sometimes split, sometimes distort, just for a moment. This effect is called gravitational microlensing. It is as if the rogue planet carries a magnifying glass, invisible until it drifts into just the right position, allowing us a fleeting glimpse. Imagine watching the sky for years. Billions of stars twinkle steadily. Then, one night, a star suddenly grows brighter, its light stretched and bent by an unseen hand. The brightening lasts hours, maybe days, and then it fades, the star returning to normal. The cause: a rogue planet, passing silently between us and the star, its gravity briefly betraying its existence. We may never see that same planet again, but for a moment, it revealed itself. Microlensing is delicate. It requires patience. It requires watching millions of stars at once. It requires luck, because the alignment must be nearly perfect. But when it works, it is powerful. It allows us to detect not just massive planets, but even those the size of Earth. This is how we know that rogue planets exist, not by light, not by reflection, but by the gentle curve of gravity itself. There is another method. Young rogue planets, freshly ejected from their systems, still glow faintly with heat from their formation. This glow is not visible to our eyes. It is infrared. Telescopes tuned to infrared light, such as Spitzer and Hubble, have spotted faint, cool objects drifting in young star clusters. Too small to be stars, too large to be dust. They are likely rogue planets, still warm from their birth. This warmth fades quickly, over millions of years. But in the youngest clusters, it allows us to catch them before they vanish completely into the dark. Astronomers have also used surveys that track the motions of faint objects against the background of stars. Occasionally, a rogue planet betrays itself by drifting slowly across the sky. Not bright, but moving. Movement can reveal what brightness cannot. Each of these methods has limits. Macrolensing gives us a glimpse, but once a rogue planet has passed, it is gone. We cannot track it further. Infrared detection works only for the youngest rogues, those still glowing with the heat of formation. The older, colder ones are lost to the night. Motion surveys catch only the nearest, and even then, they are faint shadows. And so, despite all our progress, rogue planets remain the most elusive of worlds. But new technology promises to change this. The Nancy Grace Roman Space Telescope, launching in the years ahead, will conduct a massive microlensing survey. We'll stare at the galactic bulge, where hundreds of millions of stars crowd together. In that sea of starlight, every tiny distortion will be recorded. Every hidden wanderer that passes by will be revealed. Astronomers expect Roman to find hundreds of rogue planets, perhaps thousands, perhaps more. The James Webb Space Telescope, already operating, may also glimpse faint infrared glows of young rogue planets. Its sensitivity is unmatched, allowing it to see what no other telescope can. And the Gaia mission, mapping the motions of 1 billion stars, may uncover subtle signs of rogue planets tugging at their neighbors, even if they shine with no light of their own. Piece by piece, a picture is forming. Think of the patience this requires. Years of watching, years of waiting, all for a single, brief flicker of evidence. It is like fishing in the deepest ocean, where the fish are invisible, and the only sign of their passing is a ripple in the water. And yet, astronomers persist, because every ripple tells a story. Every distortion means a world. In the end, hunting rogue planets is not about seeing. It is about listening to the subtle whispers of gravity, to the fading heat of birth, to the tiny movements across the sky. These methods are our ears in the darkness, and with them, we are beginning to hear the silent majority of the galaxy. Rogue planets may be invisible, but they cannot hide forever. With patience, with technology, with persistence, we are bringing them into view. The invisible is becoming visible. The dark is becoming known. With each discovery, we move closer to answering the question that drives us all: how many of these silent wanderers are truly out there? Not all darkness is complete. Even in the coldest night, there can be a faint glow, a whisper of heat, a reminder of what once was. So it is with rogue planets. Though they drift without stars, though they shine with no reflected light, many are not entirely invisible. Some still carry the warmth of their birth. And in that warmth, they reveal themselves in infrared. When a planet forms, gravitational energy compresses it. The collapse of dust and gas creates heat deep inside. For a time, even without a sun, the planet glows faintly. This glow is not visible to human eyes. It is not starlight, not the golden radiance of the sun. It is a low, steady warmth, the kind our skin might feel, but our eyes cannot see. This is infrared light. Infrared is the spectrum of warmth. The heat of a campfire, the body heat of an animal, the faint thermal signature of every living thing. With special instruments, astronomers can see in this hidden light. And in doing so, they sometimes catch glimpses of rogue planets, still warm from their violent beginnings. In young star clusters, stars are only a few million years old, astronomers have noticed faint, dim objects glowing in infrared. Too small to be stars, too massive to be dust. Some are likely brown dwarfs, failed stars that never ignited. But others are even smaller, flat-sized. These are thought to be rogue planets. They glow not because of a star, but because of their own residual heat. It leaks slowly into space, a dying ember fading over billions of years. The Spitzer Space Telescope, before its retirement, was one of the great hunters of these infrared ghosts. Spitzer peered into young clusters, revealing populations of faint objects that challenged classification. Were they small brown dwarfs? Were they giant planets? The lines blurred. But in that blur, a truth emerged. The galaxy is full of lonely, glowing worlds, cooling slowly in the dark. The Hubble Space Telescope also contributed. Though designed for visible light, it could capture near, infrared images. In regions like the Orion Nebula, astronomers found dim companions, objects that seemed too faint for stars. They burned not with fusion, but with the last warmth of their formation. And now, the James Webb Space Telescope, with its powerful infrared vision, is poised to push further. Just can see deeper, fainter, more precisely than any telescope before it. Already, it has begun to detect the faint glows of objects at the edge of classification, massive planets and small brown dwarfs, hovering in the no man's land between starlight and darkness. Among them may be rogues, the faintest ghosts in the cosmic night. But there is a limit. A rogue planet only glows for so long. A few million years after birth, its warmth fades, its light disappears. It becomes truly cold, truly dark, forever hidden. This means the infrared method can only reveal the youngest rogues. The elders, those billions of years old, are invisible even to the most sensitive detectors. And yet, there is power in even these brief glimpses. By studying glowing rogues in young clusters, astronomers can estimate how many there are. If we find dozens in one region, how many must there be across the galaxy? Clusters cast out planets at birth, then every star-forming region has sent wanderers into the dark. The infrared ghosts are the tip of the iceberg. They hint at the vast, unseen population beneath. Consider this: every time a star cluster forms, it may eject dozens of planets into space. Every nebula may give birth not only to stars, but to rogues. And when we see the faint warmth of just a few, we are reminded that behind them are countless others, already too cold to see. Infrared astronomy also teaches us about their nature. Some rogues appear to have atmospheres. Their faint glow can be spread into spectra, revealing molecules, water vapor, methane, carbon monoxide. These are the same gases we find in giant planets around stars. Others may even show signs of clouds, storm systems roiling in eternal night, giant whirls wrapped in blankets of gas and vapor, glowing faintly as they cool. These details remind us, rogues are not abstractions. They are worlds. Real, complex, dynamic worlds. Infrared light gives us only the briefest window. But through that window, we see that the darkness is not empty. We see the ghosts of planets, embers cooling in the galactic sea. And though they will one day fade completely, their discovery tells us something profound. For every glowing rogue we find, there are many more hidden. The darkness is crowded. The void is alive with worlds. They drift unseen, but for a little while, they glow. And in that glow, we glimpse the invisible. We realize the universe is richer than our eyes suggest. Rogue planets are not gone. They are simply waiting, wrapped in veils of night, their warmth fading into eternity. The story of rogue planets is still in its beginning. We have glimpsed them through fleeting distortions of starlight. We have caught their fading warmth in infrared. But these are only fragments, shadows. The true census of rogue planets remains hidden. If we wish to truly know how many wander the galaxy, if we wish to map the invisible, we will need new eyes. Eyes sharper, wider, more patient than ever before. Tomorrow's technology is being built today. With it, the invisible may soon become clear. One of the most promising instruments of the future is the Nancy Grace Roman Space Telescope. It is often called Hubble's wide-eyed successor. Where Hubble focused deeply on small regions of the sky, Roman will survey vast stretches at once. Its wide, field view, combined with exquisite sensitivity, makes it the perfect hunter of rogue planets. Roman will stare at the heart of our galaxy, the galactic bulge, where hundreds of millions of stars cluster together. It will watch them patiently, waiting for the tiniest flickers of microlensing events. Every time a rogue planet drifts in front of a star, Roman will record it. One after another, these invisible wanderers will reveal themselves. Astronomers expect Roman may discover hundreds of rogues. Some believe it could find thousands, perhaps even more. For the first time in history, we will have a true survey of the galaxy's dark population. Then there is the James Webb Space Telescope, already peering into the universe with unmatched clarity. Webb sees, primarily in infrared. That makes it ideal for detecting faint, cool objects, like young rogue planets still glowing from their birth. With Webb, scientists can study their atmospheres, their chemical fingerprints, their clouds and storms. It can separate faint light into spectra, revealing molecules hidden within. Water vapor, methane, carbon monoxide. Each one tells a story about what these worlds are made of. Webb cannot survey the entire galaxy, but what it can do is show us the details, the textures and layers of rogue planets we already know. It is not the census taker, it is the storyteller. And then there is Gaia. The Gaia mission is mapping over 1 billion stars with extraordinary precision. It measures their positions, their motions, their subtle shifts in light. In this vast dataset, scientists can detect when stars wobble, pulled by unseen companions. Sometimes those companions are other stars. Sometimes they are planets. And sometimes they may be rogue planets passing near enough to target the star's path. Gaia is not built to find rogues directly, but its exquisite precision makes it sensitive to the faint whispers of gravity. It may provide another avenue to uncover the unseen. Other missions are also on the horizon. The Vera C. Rubin Observatory, under construction in Chile, will conduct the legacy survey of space and time. It will image the entire southern sky, night after night, for 10 years. Comparing images across time, it may reveal faint, moving objects, rogue planets drifting against the background of stars. The Rubin Observatory will not only deepen our understanding of dark matter and galaxies, it may also provide some of the best long-term tracking of faint, wandering worlds. Consider what this means. For the first time, we will have multiple eyes on the darkness. Roman, scanning wide fields for microlensing events. Webb, peeling apart atmospheres of the faintest rogues. Gaia, mapping gravitational whispers across the galaxy. Rubin, tracking the faint, moving points against the night sky. Together, they form a new generation of instruments. Together, they are our lanterns in the void. And there is more to come. Concepts for the future include telescopes with even larger mirrors, even greater sensitivity. Some envision arrays of space telescopes working together, creating virtual lenses the size of planets. Others dream of probes that could one day travel beyond our solar system, scouting for rogue planets directly, perhaps even landing on them, perhaps even drilling into their icy crusts, searching for hidden oceans below. These are not yet realities, but the vision grows clearer each year. Technology is the bridge between imagination and discovery. Once, rogue planets were only stories. Now, because of our instruments, they are data. They are real. And as our tools sharpen, the shadows will lift further. The census will become clear. Invisible population will step into view. Think of what Roman may reveal. A sky filled not only with stars, but with billions of unseen worlds. Think of what Webb may show us. Atmospheres thick with clouds, storms raging in eternal night. Think of what Gaia may uncover. The hidden motions, the subtle wobbles, the evidence of passing rogues. And think of Rubin, watching patiently for years, catching their slow movements across the cosmos. Tomorrow's technology is not just about sharper images. It is about reshaping our understanding of the galaxy itself. Every rogue planet discovered is a reminder that the universe is richer than we thought. Every census taken, every spectrum studied, brings us closer to answering the great question: how many worlds are truly out there? The shining ones, not the easy ones, but the hidden ones, the wanderers, the invisible majority. We stand on the edge of a new age, an age when the invisible will be counted, an age when silence will be mapped, an age when the galaxy's true population, stars and rogues together, will finally be revealed, and in that revelation, our place in the universe will shift once more. How many worlds are there? It is one of the oldest questions in astronomy. For centuries, we looked at the stars and assumed they were the true citizens of the cosmos. Billions upon billions of suns, each one burning brightly, filling the galaxy with light. And planets. For a long time, we thought they were rare. Perhaps only a few stars had them. Perhaps even fewer had systems like ours. The last 30 years have rewritten that story. We now know that nearly every star has planets. They are not rare jewels. They are common. They are everywhere. And if stars are so often accompanied by planets, then what of the ones that are cast away? What of the rogues? The first surveys hinted at a staggering possibility. In 2011, a team using gravitational microlensing reported evidence of free, floating planets, roughly the size of Jupiter, drifting through the galaxy. Their conclusion was astonishing. There may be at least one rogue planet for every star in the Milky Way. One for one. Billions upon billions. Other studies suggested the number could be even higher. 2, 3, perhaps even more rogues for every shining star. If this is true, then planets do not merely accompany stars. They vastly outnumber them. The galaxy may be more a collection of worlds than of suns. Let us think carefully about the numbers. Astronomers estimate the Milky Way holds between 200 and 400 billion stars. Already, this number is almost impossible to comprehend. But if there are one rogue planet per star, that means at least 200 to 400 billion rogues. If there are 2 per star, that number rises to nearly 1 trillion. And if, as some simulations suggest, there could be many more, then the majority of planets in the galaxy do not orbit stars at all. They drift, alone, in darkness. This possibility changes everything. We once thought stars were the dominant building blocks of the universe. But if rogue planets truly outnumber stars, then our census must be rewritten. Imagine describing the galaxy not as a sea of suns, but as a sea of worlds, some lit, most dark. The very balance of the cosmos tilts. Stars may be the visible rulers, but planets may be the hidden majority. This idea also reshapes our view of planetary systems. If many worlds are lost to space, then systems like our own, stable, ordered, with planets bound to a star, may be the exception, not the rule. Most planets may not belong to families. They may be exiles. They may be wanderers. The familiar model of a star, with planets, may not be typical. It may be unusual. Think, too, of what this means for life. If rogue planets are numerous, then the number of possible habitats multiplies. Even if only a small fraction can sustain warmth and oceans, the sheer number makes the odds astonishing. Life may not only exist around suns. It may thrive in hidden oceans, in subsurface seas, in the darkness of rogues. Our search for life cannot stop at the stars. It must expand to the invisible. But how certain are we? The truth is, the census is still young. Macrolensing gives us hints, but each event is rare, difficult to repeat. Infrared surveys show us only the youngest rogues, glowing faintly before fading into eternal dark. Simulations suggest vast numbers, but simulations are only models, not proof. We stand at the threshold of discovery. We sense the enormity of the rogue population, but we cannot yet count them all. That is why the future missions matter so much. The Roman Space Telescope, with its wide-field microlensing survey, may at last provide real numbers, not guesses, not hints, but a statistical census of rogue planets. For the first time, we may know, are there one per star? How many billions of wanderers drift unseen? Until then, we live with awe and uncertainty. Perhaps the galaxy is dominated by stars, and rogue planets are only a minority. Or perhaps the opposite is true. Perhaps the stars are only the tip of the iceberg, their light hiding a far greater population of worlds in the dark. In that case, the very image of the universe changes. We would no longer say we live in a galaxy of stars. We would say we live in a galaxy of planets, with stars scattered among them. Think of the humility this brings. When we look up at the night sky, we see brightness and assume it is everything. But the true majority may be what we cannot see. The darkness may hold far more than the light. Rogue planets remind us, the universe is not what it seems. It is richer, stranger, more abundant. So how many rogue planets are there? We do not yet know. But the best estimates suggest billions upon billions. Enough to outnumber the stars. Enough to change our cosmic census forever. And as we await the surveys of tomorrow, we live with this staggering possibility that the silent wanderers of the galaxy are not the minority but the majority. What does it mean if rogue planets truly outnumber the stars? It is not only a matter of numbers. It is a matter of perspective. A shift in how we see the galaxy, how we imagine its birth, and how we understand its destiny. For centuries, our picture of the Milky Way was simple, a great spiral of stars, hundreds of billions of suns, each one a beacon of light. The stars were the building blocks, planets were the companions. But if planets, especially rogue planets, are more numerous, then the very foundation of our cosmic story must change. First, it alters our view of planetary systems. We imagined solar systems as stable families, a star at the center, planets in orbit, moons circling planets, a tidy order, a cosmic model we projected from our own. But the reality is more violent. If billions of planets are cast into space, then systems are not stable at all. They are chaotic. They are battlegrounds of gravity. Planetary birth is not gentle. It is turbulent, with collisions, ejections, and endless reshuffling. The rogues are the evidence, proof of the disorder behind the apparent harmony. Second, it changes how we see galactic formation. When galaxies form, they are shaped not only by stars and dark matter, but also by the billions of planets scattered through them. Though a single planet's gravity is small, the combined mass of trillions of rogue planets may be significant. They may help shape the distribution of matter in the galactic disk. They may influence how stars cluster, how spiral arms form. galaxies evolve over billions of years. Rogue planets are not just passengers. They are part of the machinery. Third, there are implications for interstellar travel and exploration. If rogue planets are everywhere, then the spaces between stars are not empty. They are dotted with worlds, stepping stones in the galactic ocean. A spacecraft traveling between stars might pass near one, might use its gravity for a slingshot, might even land, if the conditions allow. In the far future, humanity may find that these dark wanderers are waypoints, harbors in the deep night, markers along the endless road between suns. Fourth, the abundance of rogue planets deepens the mystery of life. If billions of them exist, then even if only a fraction have conditions to sustain oceans beneath ice, the number of potential habitats multiplies beyond imagination. We once thought life must cling to stars. Now, we must admit, life may cling to darkness as well. To geothermal heat, to radioactive decay, to the hidden energy locked in planetary cores. The rogues suggest that the universe may be far more alive than we thought. But perhaps the greatest implication is philosophical. For all of human history, we have worshipped the light, the sun, the stars, the glowing lanterns of the sky. We believed the luminous was the truth and the darkness was empty. But rogue planets remind us the darkness is not void. It is full. It is crowded. It may even be dominant. The universe, then, is not a place where light rules over emptiness. It is a place where darkness is rich, where the unseen outweighs the seen. This humbles us. It forces us to let go of old assumptions. It invites us to imagine reality beyond what our eyes can see. There is also a connection to dark matter, the mysterious substance that makes up most of the universe's mass. Rogue planets are not dark matter. They are far too few, too ordinary, to explain that cosmic mystery. The fact that they exist in such numbers reminds us how much of the universe is hidden, how much lies beyond sight. If trillions of planets can drift unseen, then what else might fill the darkness? What other populations, structures, or phenomena await discovery? The rogues are a lesson. Never assume emptiness. The void is always richer than we think. Imagine the galaxy now. Not just a spiral of stars, but a spiral of worlds. For every sun that shines, several dark companions drift nearby, unbound, invisible, yet real. Between the stars, the galaxy is crowded, not empty. Every cubic light here may hold more than we guess. Every patch of darkness may hide a giant. This is the new picture of the Milky Way. Not only a city of stars, but an ocean of planets. And so, the implications are vast. For planetary science, rogues prove that formation is violent, that systems are unstable, that exile is common. For galactic science, rogues add mass, help shape structures, and contribute to the dynamics of galaxies. Astrobiology, rogues expand the possible abodes of life far beyond the circles of starlight. For philosophy, rogues teach us to value the unseen, to respect the darkness, to accept that the majority of reality may lie beyond our senses. If rogue planets truly outnumber stars, then the story of the universe is not a story of shining suns alone. It is a story of hidden worlds, drifting silently, waiting to be counted. And once we accept that, our place in the cosmos changes. We are not only children of a star. We are citizens of a galaxy filled with wanderers. The Milky Way is not only a gallery of lights, it is a home for darkness and for the worlds that dwell within it. What is life without light? On Earth, life seems inseparable from the sun. Plants reach for it. Animals depend on it. Our very sense of time, day and night, is tied to the rhythm of its rising and setting. It is easy to believe that without sunlight, life could not exist. A rogue planet, drifting in eternal night, seems at first glance a frozen tomb. A world without a star, without warmth, without hope. But the universe is never so simple. Life has a way of surprising us, of thriving where we least expect it. And so we must ask, could there be life in the darkness of rogue planets? Answer, let us look first at Earth itself. Far beneath our oceans, in the blackness where no sunlight penetrates, exist entire ecosystems. Around hydrothermal vents, life flourishes. Bacteria feed not on sunlight, but on the minerals rising from Earth's core. Giant tube worms, strange crabs, and ghostly fish all thrive there, living not by photosynthesis, but by chemosynthesis. These creatures prove a profound truth. Life does not need light. Life only needs energy. Now, imagine a rogue planet. Its surface is frozen. Its skies are black. But deep below, its core still stirs with heat. Radioactive decay warms it. Residual energy from formation lingers. Perhaps even tidal forces, if it carries a large moon, continue to churn its interior. That heat could melt pockets of water beneath the ice. Subsurface oceans, sealed away, stable for billions of years. In those oceans, conditions could resemble the vents on Earth. Bacteria could feed on chemical energy. Entire ecosystems could rise around invisible heat sources. Life alien, hidden, enduring, could thrive in the dark. There is another possibility. If a rogue planet retains a thick atmosphere of hydrogen, it could trap heat like a blanket. Even without a star, its surface might remain surprisingly warm. In theory, a planet with a dense enough atmosphere could sustain liquid water on its surface despite drifting through interstellar space. Imagine walking across such a world. The sky would be black, but the air thick and hazy. The ground damp, perhaps even covered in shallow seas. No sun, but not frozen, not dead. A planet that is warm without a star. What would life look like on such a world? Without light, vision may never evolve. Creatures may navigate by touch, by vibration, by electric or chemical senses. Plants, as we know them, would be impossible. But other forms of energy, gathering life could arise, feeding on heat, on chemical reactions, on processes we can barely imagine. Perhaps entire alien ecologies drift in the dark, never knowing the warmth of a star, but alive nonetheless. If rogue planets are as numerous as stars, then the possibilities multiply. Even if only 1 in 1,000 holds an ocean beneath its ice, that still means billions of hidden seas across the galaxy. Even if only 1 in 1,000,000 sustains complex life, that is still thousands upon thousands of worlds. The math is overwhelming. The darkness may be full of life. This changes the search for extraterrestrial intelligence. For decades, we have focused on stars. We listen for signals from planets in the habitable zones around suns. We assume life, like us, clings to light. But rogue planets remind us to look elsewhere, to listen differently, to expand our imagination. Life may not announce itself with radio waves. It may whisper in oceans deep beneath ice, never breaking the surface, never shining into the sky. If so, we may never hear it. But it may be there. Vast, abundant, unseen. The idea is humbling. We may share the galaxy not only with civilizations circling stars, but with countless hidden ecosystems on worlds that never see daylight. These life forms may never look at the stars. They may never build telescopes, never wonder about the cosmos. Their entire universe may be an ocean beneath ice, lit by geothermal glow. And yet, they would be alive. Proof that life is not bound to suns. Proof that existence can flourish even in exile. It is tempting to think of rogue planets as empty, cold rocks drifting through space. But when we consider Earth's deep oceans, when we consider the possibility of thick atmospheres, we realize that darkness does not mean lifelessness. It may mean hiddenness. It may mean survival in silence. And if life can thrive without light, then life may be far more common than we ever imagined. So could life exist on rogue planets? The evidence on Earth suggests yes. The physics of heat retention suggests yes. The vast numbers of rogues suggest yes. The answer is not certainty. The answer is possibility. And that possibility is profound, because it means that when we look into the dark, we are not looking into emptiness. We may be looking into the homes of billions of hidden lives. Life in darkness is not impossible. It may be inevitable. It may already be thriving, quietly, patiently, waiting in the eternal night. And if so, then the universe is far richer, far stranger, and far more alive than we ever dared believe. If we wish to imagine life on rogue planets, We need not look to distant stars first. We need only look here, to Earth. Our world is often seen as a planet of sunlight. Plants drink in its rays, animals follow the cycle of day and night. Humans wake and sleep by its rhythm. But beneath the surface, in the hidden places of our world, life tells a different story. A story that does not depend on the sun. A story that shows us how existence can flourish in darkness. Consider the deep ocean trenches. At depths where sunlight never reaches, life thrives. Entire ecosystems exist in perpetual night. Strange fish with luminous bodies, squid that flash signals in the dark, creatures that never once see the sun, yet live full lives. How do they survive? By feeding on organic material that drifts down from above, by adapting to cold, crushing pressure, by turning darkness into home. If life can adapt so perfectly to a sunless ocean, why not to an ocean on a rogue planet? Now picture the hydrothermal vents on the ocean floor. Here, jets of mineral-rich water gush from Earth's crust. The water is boiling hot, yet surrounded by ice-cold sea. Around these vents live giant tube worms, crabs, and entire colonies of bacteria. Do not use sunlight. They use chemical energy. They feed on hydrogen sulfide, on minerals, on heat from Earth's inner fire. This is chemosynthesis, life built on chemistry, not light. These organisms show us that the essential ingredient for life is not starlight, but energy in any form. A rogue planet, with heat in its core, with chemical reactions in its oceans, could sustain the same. Then, there is the ice of Antarctica. Beneath miles of frozen desert, beneath glaciers older than human memory, scientists have found microbes alive. In Lake Vostok, sealed beneath 4 kilometers of ice, life persists in isolation. Trapped for millions of years, without sunlight, without open air, but still alive. On a rogue planet, oceans beneath ice could be even larger. Sealed away from the void, protected by kilometers of frozen crust, they too could nurture life. Consider also the caves of Earth. Deep underground, in total darkness, microbes cling to mineral walls. They survive on trace chemicals, on reactions between rock and water. In the hot, pressurized depths, they form entire hidden biospheres. If Earth can sustain life kilometers below the surface, why not a rogue planet? Why not in its crust, in its hidden veins of warmth? And then there are the deserts, scorched by heat by day, frozen by cold by night, seemingly barren. Yet in the cracks of stone, tiny microbes survive, dormant for years, awakening when water comes. This too is a lesson. Life is not only resilient in abundance, it is patient in scarcity. It waits. It endures. A rogue planet may not always provide, but where it does, life may cling to the smallest opportunity. Everywhere we look on Earth, life finds a way. In acid pools, creatures swim. In radioactive waste, bacteria feed. On the frozen tundra, lichens survive. Even in the upper atmosphere, microbes drift in thin air, tolerating conditions deadly to most. Our planet proves a universal law: life is adaptable. Life does not require perfection. It requires possibility. This is why rogue planets fascinate scientists. If life can exist without light on Earth, if it can live on heat, on chemistry, on persistence, then why not beyond? Why not on a world cast into the void, with oceans beneath ice, with vents of heat, with minerals to feed upon? The lessons of Earth whisper and answer: yes. Yes, life could exist. Yes, it could thrive unseen. These lessons also remind us of humility. When humans first searched for life, we looked for Earth, like worlds, sunlit, temperate, familiar. Earth itself tells us, life does not need Earth, like conditions. It only needs energy and time. The universe provides both, in ways stranger than we once believed. So when we wonder about rogue planets, we need not imagine from nothing. We already have examples: deep oceans, sealed lakes, endless caves, silent deserts, each one a rehearsal for life in the dark. each one proof that existence can endure without stars. Perhaps one day, a probe will land on a rogue planet. It will drill through ice. It will sample water. And in its lens, it may reveal a microbe swimming freely, alive in the night. In that moment, we will remember the lessons of Earth. We will remember that life is not fragile. It is fierce. It is inventive. It is patient. And it does not need light to exist. For decades, when scientists spoke of extraterrestrial life, they spoke of stars. They searched for Earth like planets orbiting suns, worlds in the so-called habitable zone, where liquid water might exist on the surface. They aimed radio telescopes at nearby stars, listening for signals. They dreamed of civilizations looking back at us, their worlds bathed in starlight. But what if we have been looking in the wrong place? What if life thrives not in the glow, but in the darkness? What if the galaxy is alive not only around stars, but in the exile between them? If rogue planets are as numerous as stars, then the possible abodes of life multiply beyond comprehension. Even if only a small fraction can support oceans beneath their ice, the numbers are staggering. Billions of hidden seas. Billions of chances for biology to spark. The question then changes. It is no longer is there life out there, but how many billions of forms of life are we failing to see? Think of it, civilizations that arise around stars are rare and luminous. But what of life that never sees the stars? Life that evolves in oceans beneath kilometers of ice, life that never breaks the surface, never builds telescopes, never learns of galaxies. It would be life nonetheless. Real. Complex. Alive. But silent. Unseen. Unknowable to us. The galaxy could be teeming with such life, not civilizations, but ecosystems, thriving in the dark. This realization expands astrobiology. We must search not only for signals in radio bands, but for chemical whispers in atmospheres. We must look not only at planets near stars, but at the faint distortions of rogue planets passing by. We must consider that life may be abundant, but quiet. Not technological. Not communicative. Not visible. Yet alive in forms that broaden our imagination. There are also profound philosophical implications. We have long tied our sense of importance to our star, to our planet, to the uniqueness of our conditions. But if life can exist in the dark, if it can thrive without starlight, then life is not fragile. It is not rare. It is woven into the fabric of the universe. Perhaps life is the rule, and lifelessness the exception. Perhaps the cosmos is not silent, but humming with hidden biology in places we never thought to look. For the search for extraterrestrial intelligence, Hetty, this is both inspiring and humbling. Inspiring, because it means life is abundant. Humbling, because it means intelligent, technological civilizations may be rarer than life itself. If billions of rogue planets host microbes, that is a triumph of biology. But if only a few develop civilizations, then we must accept that intelligence may be the outlier. We may be one of the few, or perhaps not. But the rogues remind us, life and intelligence are not the same. The galaxy could be full of life, and still mostly quiet. Consider the Fermi paradox, the question of why. If life is common, we have not yet detected other civilizations. Rogue planets offer one answer. If most life evolves in darkness, beneath ice, in oceans sealed away, then it may never build radios. It may never send signals. It may never know the stars even exist. Such life would never announce itself. And so the galaxy could be full and still silent to us. Yet even this silence has meaning. Because it tells us that life is resilient, that biology is not bound to stars, that the cosmos is richer, more mysterious and more abundant than we once dreamed. And perhaps, somewhere among the billions of rogues, there are exceptions. Perhaps one world has oceans shallow enough for creatures to climb to the surface. Perhaps they evolved senses adapted to eternal twilight. Perhaps, against all odds, they looked up into the black sky and wondered. Even if they saw no star, they may have asked the same question we ask. Are we alone? The search for extraterrestrial life must change. We cannot limit ourselves to circles of starlight. We must expand our imagination to the invisible, to the wanderers, to the rogues, Future missions may not only scan stars, but also watch the faint flickers of microlensing. They may not only seek light, but also search for heat. They may not only listen for radio, but test for chemical signatures in sealed oceans. The rogues demand that we widen our gaze. For humanity, this carries a deeper message. If life thrives in darkness, then life is not fragile. It is not dependent on narrow conditions. It is abundant. It is adaptable. It is cosmic. This gives us hope. Hope that life is not unique to Earth. Hope that the galaxy is alive, even if we never hear its voices. The rogues may never shine. They may never send signals, but they may carry the greatest secret of all, that the universe is full of life, quiet, hidden, yet everywhere. Long before astronomers confirmed their existence, rogue planets lived in the imagination. Writers, filmmakers, and dreamers saw in them something haunting, something poetic, something that spoke to the human condition. A world without a star. Journey without a destination. A life adrift in endless night. It is an image that resonates deeply, because in many ways it mirrors our own search for meaning in a vast, indifferent cosmos. In the early 20th century, science fiction stories began to toy with the idea of wandering worlds. Some imagined them as threats, planets on collision courses with Earth, harbingers of disaster. Others saw them as mysterious realms, places where lost civilizations might hide. To storytellers, rogue planets were both danger and wonder. They could arrive suddenly, a dark visitor from the void. They could carry secrets unknown. Films and novels in later decades expanded on these themes. One story might depict a rogue planet passing near Earth, its gravity threatening to tear our world apart. Another might imagine humans landing on such a planet, discovering strange life in its frozen oceans. Sometimes these worlds were hostile. Sometimes they were sanctuaries. Always they carried mystery. Why do rogue planets capture our imagination so strongly? Perhaps because they embody loneliness. A planet without a sun is a metaphor for exile. It belongs to no family. It drifts without purpose. And yet, there is also resilience. The rogue planet endures. It continues its journey, whether anyone sees it or not. In that endurance, we see ourselves. Humanity, too, drifts through the void, searching for belonging, searching for meaning. Some works of fiction use rogue planets as symbols of hidden possibility. Dark world appears, and within it lies treasure, or knowledge, or alien civilizations waiting in silence. The idea that something so vast could remain unseen is both unsettling and exhilarating. If entire worlds can drift unseen, what else might the universe be hiding? In other stories, rogue planets are homes. Human refugees escaping dying stars. Civilizations traveling on worlds untethered, carrying their cultures across the galaxy. A rogue planet, in this vision, is not a symbol of exile. It is a vessel, a sanctuary, a moving ark. It transforms from loneliness to hope. The metaphor extends further still. For some, rogue planets represent the unknown futures of humanity. Our world is bound to the sun, but one day, billions of years from now, the sun will swell and die. What then? Might Earth itself be cast adrift, a rogue planet wandering the galaxy, carrying with it the remnants of life, carrying with it the story of humankind? It is a chilling thought, and yet, it is also a reminder of endurance. Even without a star, a world can go on. Perhaps so can we. In fantasy and myth, like science fiction, rogue planets often take on spiritual meaning. They are the lost souls of the galaxy. They are omens. They are places of testing, where heroes confront darkness, both external and internal. Stepping onto a world with no sunrise is like stepping into one's own fears. It forces characters and readers to imagine life without guidance, without certainty, without light. And yet, in facing this darkness, new strength is found. The imagery of rogue planets also appeals to our sense of cosmic scale. We look at the night sky and see stars, but to imagine worlds drifting invisibly between them reminds us how small our knowledge truly is. It humbles us. It excites us. is the essence of science fiction, to see beyond what is known, to fill the silence with possibility. Modern science fiction has only deepened this fascination. As astronomy reveals more about rogue planets, writers weave these discoveries into their tales. Stories now imagine oceans beneath ice, life thriving in geothermal heat, civilizations hidden in the void. What was once only speculation is now anchored in science. The line between imagination and reality blurs. And in truth, perhaps science fiction was ahead of science all along. Long before telescopes glimpsed microlensing events, long before infrared surveys found faint glows, writers were already dreaming of wanderers, already asking, what if the galaxy is full of unseen worlds? Now science answers, yes, they are real. And yes, they may be numerous. Fiction prepared our minds for this truth. It softened the ground of imagination. It allowed us to accept the unbelievable. So rogue planets live in two realms. In science, they are data points, gravitational distortions, infrared signatures. But in fiction, they are mirrors of our fears and hopes. They are symbols of loneliness and endurance. They are canvases on which we paint the unknown. Both realms matter. Both shape how we understand the universe. Because science tells us what is, but fiction reminds us what it could mean. The rogue planets of our imagination will continue to evolve. As telescopes reveal more, as discoveries confirm their abundance, new stories will emerge. Some will see them as homes for hidden life. Some will see them as harbingers of danger. Some will see them as metaphors for ourselves. But all will see them for what they are, mysteries that stir both the mind and the heart. In the end, science fiction did not invent rogue planets. The universe did. But fiction gave them meaning long before science gave them proof. And in that union, between discovery and imagination, our understanding of the cosmos deepens. The rogues are real. The rogues are symbolic. And in both ways, they remind us that the universe is always larger, always stranger, always richer than we believe. What will humanity's future look like among the stars? For centuries, we have dreamed of visiting other worlds. First the moon, then Mars, then perhaps the moons of Jupiter and Saturn. Always our eyes turn toward places bathed in starlight. But what if the great stepping stones of the future are not shining planets at all? What if they are the silent wanderers? What if rogue planets become humanity's harbors in the void? Imagine a far future, when spacecraft leave our solar system in search of other stars. The distances are immense. Even the closest star, Proxima Centauri, is more than 4 light years away. Across such gulfs, ships will need resources, rest stops, places to gather strength along the way. At first, space may seem empty. But if rogue planets are numerous and the void is dotted with waypoints, giant worlds drifting in the dark, waiting to be found. Picture a ship approaching one. Instruments detect its gravity. Its outline emerges from the darkness. Perhaps it is a giant like Jupiter, a swirling world with thick atmosphere. Perhaps it is smaller, an icy globe hiding an ocean below. The crew descends. They land on frozen plains beneath black skies. No sunrise greets them. But the planet offers minerals, perhaps even subsurface water. It becomes a place to refuel, to gather, to survive. A station not bound to a star, but drifting freely, a cosmic port in eternal night. The possibilities stretch further. Some rogue planets may retain thick atmospheres. If humanity builds domes or habitats, those atmospheres could provide protection from radiation, even heat to trap warmth. Others may harbor subsurface oceans. Future explorers might drill through ice, reaching liquid water beneath. There, they could find resources, or perhaps even life. The rogues could become not only waypoints, but destinations in their own right. Consider also the long term. As stars age and die, civilizations may seek refuge. Rogue planets, already adrift, are not tied to the fates of suns. They may wander for billions of years, stable in their isolation. But advanced civilizations settle on them. Could they build underground cities, powered by geothermal heat, living in warmth while the surface freezes above? It is not impossible. It may even be practical. A rogue planet offers stability. It drifts slowly, unchanging, carrying its resources quietly through the galaxy. Humanity, too, might one day embrace such worlds. We think of colonizing Mars. We dream of outposts on Europa, Tyson, Enceladus. But in the very far future, when interstellar travel is reality, rogue planets may be just as valuable. Imagine an interstellar highway, ships traveling from star to star, pausing along the way at wandering worlds. Each rogue planet becomes a stepping stone. Each one shortens the impossible distance between suns. The void becomes less empty. The journey becomes less lonely. There is another possibility, one that blends science and imagination. Could humanity one day engineer a rogue planet into a home? If we find a large enough world, we might terraform it, thicken its atmosphere, warm its interior with fusion power, turn its frozen oceans into seas. It would not orbit a star. Its sky would remain black. But within domes, beneath skies of our own making, human civilization could thrive. It would be a city not tied to any sun, but to itself. A drifting world carrying humanity into eternity. Such visions may seem distant, perhaps even fanciful. But remember, not long ago, even the idea of walking on the moon was fantasy. Not long ago, exoplanets themselves were unproven. Not long ago, rogue planets were only whispers in fiction. What seems impossible today may be inevitable tomorrow. The future among rogues also raises questions of philosophy. If we settle such worlds, what will it mean to live without a sunrise? To wake each day to a black sky? To live in a place where time is not measured by orbit, but by choice? Perhaps it will change how we think of ourselves. Perhaps it will free us from dependence on stars. Perhaps it will make us, like the rogues, wanderers in our own right. There is poetry in this vision. Humanity, a species born on a sunlit world, becoming a civilization of darkness, finding life not only in the light, but in the shadows. Becoming, in a way, like the planets we discover, adaptable, resilient, capable of enduring even in exile. In the grand sweep of time, our star, the sun, will not last forever. It will swell. It will fade. It will die. But rogue planets do not depend on suns. They drift for billions of years. They are timeless wanderers. Perhaps one day, humanity's survival will depend not on the stars, but on these dark worlds. Perhaps our destiny is not only to circle suns, but to ride with the rogues, becoming citizens of the night. So when we think of the human future among the stars, we must also think of the human future among the dark. Rogue planets may be more than mysteries. They may be opportunities. They may be homes. They may be the bridges that carry us into eternity. And in embracing them, we may find not only survival but a deeper belonging in the galaxy we call home. Look once more at the night sky. The stars glitter above, radiant and countless. They seem eternal. They seem to be the true rulers of the universe. But now, after our journey, we know the truth may be different. The lights we see may not be the majority. The true citizens of the cosmos may be hidden, silent, dark, wandering worlds. Every star that burns, there may be a rogue planet drifting unseen. Perhaps 2, perhaps 10, perhaps more. The galaxy is not only a sea of suns, it is an ocean of worlds. Some orbit, some drift, some glow, most do not. We live in a universe not of emptiness, but of abundance, not of silence, but of hidden voices. Rogue planets remind us of the violence of creation. They are the exiles, hurled from their systems in chaos. They are the children of collisions, the evidence of instability, the scars of galactic birth. And yet, they also remind us of resilience. Cast away, they do not vanish. They endure. They continue their journeys through the void. They remain, silent and strong. They also expand our imagination of life. If oceans can exist beneath ice, if heat can rise from planetary cores, then even in darkness, life may thrive. Perhaps not civilizations like ours, but ecosystems rich and strange. Perhaps the galaxy is filled with hidden oceans, teeming with life that never sees the stars. Perhaps the silence of the universe is not emptiness, but simply life living quietly in the dark. For humanity, the rogues hold both mystery and promise. They are challenges, for they are hard to find, hard to study, hard to imagine. But they are also opportunities. They may be waypoints for interstellar travel. They may be homes for future civilizations. They may one day carry us beyond the death of our star. The rogues whisper of survival. They suggest that our destiny may not be bound to the sun, but to the galaxy itself. Philosophically, they ask us to rethink what matters. We have always worshipped the light. We have always trusted what shines. But the rogues teach us that darkness, too, is full. That what is unseen may outweigh what is visible. This is a lesson not only about the cosmos, but about ourselves. We are drawn to brightness, but we must learn to see value in what lies beyond sight. In silence, mystery, in possibility. Think of the poetry of this. A galaxy where stars dazzle but unseen worlds dominate. A universe where what we see is only a fraction and what we cannot see is the true majority. The rogues are the hidden architecture, the silent background, the uncounted population. They remind us we do not yet know the universe. We have only begun to glimpse its true face. And so, we return to the question, are rogue planets more common than stars? We do not yet know for certain, but all evidence suggests yes. The invisible may outweigh the visible. The silent may outnumber the loud. If so, then our cosmic census is transformed forever. We live not in a galaxy of stars, but in a galaxy of planets, with stars scattered among them. As we end this journey, let us pause in wonder. Above us, the stars shine proudly. But around us, unseen, drift billions of worlds. They are dark. They are silent. But they are real. And in their hidden numbers, they redefine what the universe is. Rogue planets are not just curiosities. They are reminders. Reminders that reality is larger than perception. That the universe is richer than light alone can show. That we must always look deeper, listen longer, imagine further. Because the greatest truths may not be in the brightness, but in the shadows. So look again at the night sky. See the stars. Admire their brilliance. But remember the rogues. Remember the invisible worlds that drift between. Remember that the cosmos is not only what shines, but also what hides. And in that knowledge, feel wonder. Feel humility. Feel belonging. Because we, too, are wanderers in the galaxy, children of a star, but citizens of a universe filled with rogues.